Okay, these are your notes for solving systems of equations by graphing. These are the same problems we're going to do in class. This note are just in case you need extra help or you are gone. Okay, so here's your warm-up. You can go ahead and pause if you would like. You can go to the lesson and open the Google Drawing to allow you to make your graphs, but I'm going to graph them for you. So to graph these, we are going to, they're in slope-intercept form. We'll go ahead and graph it. If not, we put it in slope-intercept form. So I make a point at the y-intercept, and then the slope is -3/1. So I'm going to go down 3 to the right one, up 3 to the left one. Make my line straight as I can make it. That's a review. Okay, this review from last semester. So for this one, it's not in slope-intercept form. I'm going to get y alone. So I need to divide everything by 2. So I'm graphing y equals -3/2 x plus 2. So I make a point at 2. Slope is down 3 to the right 2, or up 3 to the left 2. Make your line. With your line tool, you should be able to do it a little straighter than that. Okay, so just a couple applications. I'm going to show you kind of where we're headed with this. Here's an example. There's these two alligators. They were different weights when they were born, and one of them is growing faster than the other one. So eventually we'll be able to write equations for that. So alligator 1 weighs 4 pounds, and he's growing at 1.5 pounds per month. Alligator 2 weighs 6 pounds, and growing at 1 per month. So right now, the one is bigger than the other. The question is, when will they weigh the same? And so if you look, this first graph here is the red one, and the second is in blue. And so right now, the one starts higher than the other, but it's not rising and running at the same rate. So after 4 months, they'll both weigh 10 pounds. That's the kind of thing we're going to do when we get done, learn how to solve. We'll do some application. Here's another example. There's a class called economics that some of you will take, where you find out where profit happens. And if you ever have a business, your break-even point is where you don't make any money, you don't lose any money. Anything after that is profit. So today, we're going to learn how to solve systems by graphing. We're going to practice, and there's a Canvas quiz. These are all the different things that will be in this unit. It says chapter 6. It's actually chapter 5, unit 5. Okay, so take a look here. And want just to look at these equations and say, what do you notice? And so before, when we solved equations, there was only one variable. But on all of these, we have an x and a y. The other thing maybe you notice is they're all linear equations. So we're going to be able to solve for 2 variables. So our answer will always be an x and a y. And these are called systems of equations. Solution is an ordered pair. And the solution works in both equations. So for instance, it says, is 4,2 a solution to the system of equations? So x is 4 and y is 2. I can plug that into both equations and see if it's true. So 4 minus 2 is true. 4 plus 4 times 2, we're going to see if that's equal to 12. And so that's true. So if it works in both equations, it is a solution to the system of equations. It's 2, 1, a solution. So we plug in 1 for y and 2 for x. So for that first equation, we get 1 equals 4 minus 3, so it works. For the second equation, x is 2, y is 1. 2 minus 1 is 1. 1 does not equal 3. So this would not be a solution So if they give you a solution, you check it, you're just plugging numbers in. Mostly we're going to solve by graphing. So basically you just graph both lines and find the point where they intersect, and that is the solution. So you need to, if you didn't already, go to your lesson and open this file. It says open this document, and basically it's a Google Draw, and there's a tool over here that has a line, and so you can make your lines on that and find where they intersect. If you have graph paper still, you can use that as well if you'd rather use graph paper, but some of you I know are out of graph paper. Okay, so basically following those directions, we're just going to graph both lines. So y equals 2x minus 4. That's a y-intercept down here. The slope we write as a fraction. Up 2 over 1, make your line. Make a point here. The slope is negative 3. Down 3 over 1. You can even see when you make your points where they're going to intersect. I have a nicer version of it. So right here is where they intersect. The coordinate of that point is 1, negative 2. So 1, negative 2 is the solution. Notice there's two answers. Same thing for the next one. Graph it. Graph the first line. Make sure you write the slope as a fraction. Graph the second line. See where they intersect. There's a nicer version of the line. They intersect right here. They always should intersect at a nice point when you're graphing, especially by hand. If you're doing it on Khan Academy, they might not be perfect, but you can tell where they're at. So the coordinate of that point is 1, 1. So that would be the solution to my system. It would work in both of these equations. Okay, you try one of these. Pause your computer right now and graph it. So when you graph, this is our point where they intersect. X is 3, y is 2. And this next one is not as easy. So we need to solve for y. It's not in graphing form right now. So we want to go ahead and solve it for y. So get y alone. There's your first line. Remember, that's a 1 right there. So we're going to divide everything by negative 1. So that second equation is 2x minus 3. First equation. Now we've changed it into slope, intercept, so we can graph it. The points intersect here. That means x is 1, y is negative 1. That's my solution. I can always check it back in my equation to make sure it works. Okay, number 5, y equals negative 4. Special case, horizontal line. Everywhere that y is negative 4. Second equation, 2x plus 2. I start at positive 2, go up 2 over 1. But for this one, you may want to go down 2 to the left 1. And sometimes if you just make those points, you can see where they're going to intersect. So it's going to intersect right here, which is negative 3, negative 4. The second one, I need to solve for y first. The shortcut with that negative 1 there is just to change both of these signs. Okay, so I got to do it for the second equation as well. Negative x minus 3. The shortcut, change everything. So I have two equations. Y equals x plus 3. That the slope is up 1 over 1. I'm going to go down 1 over 1 this way. And I'm not even going to draw my lines in yet. Second equation, 7x minus 3. So I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7 over 1. So there, right there is where they're going to intersect. When I draw that line, they're intersecting right there, which is 1, 4. If you're not sure if you have the solution, you can go back up and plug in 7 times 1 is 7, minus 4 is 3. That's 3 equals 3. Go to the second equation. 1 minus 4 should be negative 3, and 1 minus 4 is negative 3, so that's definitely a solution. X equals negative 3. That's a special case of vertical line. For the second one, I need to solve for y. Divide everything by negative 3. Be careful with your signs. So y equals 2/3 x plus 1. The two negatives make a positive. So there's my plus 1. I go up 2 over 3. That's going to take me away from my solution, so I'm going to go down 2 to the left 3. So you can see with the x's right there is where your solution happens, which is at negative 3, negative 1. Number 8, again, I have to solve for y. So y equals negative 2x minus 1. There's nothing to divide by. Second one, I solve for y. Y equals negative 2x plus 4. So let's graph both of those. You might notice they have the same slope. Graph the first one. Positive 4 is my y-intercept. Down 2 to the left one. Oops, sorry, down 2 to the right one. I'm going to just make some x's. The second equation, I start at negative 1. I go down 2 over 1, down 2 over 1. And you notice that these two lines are parallel. It means they don't intersect. Well, if the solution is where they intersect, when they don't intersect, that means there is no solution. So there are some special cases, just like there were before. If they don't intersect, there's no solutions. If they intersect, there is one solution. There's your no solutions. If you graph them, if they happen to be the same line, there's an infinite number of solutions. When you go to solve for y, if you get the same line. So those are 3 special cases. If you just keep your definition in mind that if they intersect, that's where the solution is, you can keep those straight. So you have a partner check we're going to do in breakout rooms. If you miss class, you can just work these out, okay? And you can check the solutions. So pause right now, work them out. First one. Second one. The third one. There's the fourth one. Again, remember those special cases, y equals 4, negative. So those are your notes. Make sure you take a picture and submit them on Canvas.